Our SSE group project presentation. In the scenario of COVID-19 pandemic, we would like to provide a home service system as an online platform that connects users and service providers for various home-related tasks, such as cleaning, maintenance, and repairs. The system will allow users to find, book, and pay for their home service efficiently while ensuring security and COVID-19 restriction. Next, I would like to introduce our key functionalities. First of all, we have to have a user restriction and authentication system that could allow users register and log in via email or any third-party providers, for example, Google. We are using Firebase for secure authentication platform, and we have enabled a multi-factor authentication. Next, we have a role-based access control system, which is allow different user roles are defined to control different access to different data and actions. For example, customers only could booking service, and admin could delete any service that should be cancelled. Then is our major functionality. It's general service booking. So general service booking will allow user to input their email address and home address to booking a general service or a valuable service package. And we have a special service booking, which we have integrated with Google Map to match our COVID-19 high-risk area restriction. That could allow users search for nearby available workers, review their profile, and book for a service. And then we have a secure payment processing function, which integrated with Stripe API. That ensures credit card information is securely handled without being stored in our system. At the end, we have some method that contributes to secure data transmission. That including HTTPS, which could securely handle sensitive information like user address or payment details during the transmission of those sensitive data. Next, our colleague will introduce you about the privacy issues that we're facing during the design.
Okay, I will focus on some of the key issues and pitfalls our system faces in securely use your data. First, I want to tell about making resident data secure. Use your entry resident address for server matching, but do not store them secretly, resulting in potential systems information be leaked. The second is credit card data protection. The user credit card details are not adequately protected during payment process, leading to risks such as absence or data leakage. System complexity is also a challenge. Integrations with multiple third-party systems, such as payment and geocoding servers, add complexity which can lead to configuration issues and vulnerabilities. The final concept is the Firebase. Configuring the Firebase configuring multiple times can lead to connections files that can compromise system reliability and security. Change them into a speech requires specific meaning does not change. Next, by my next classmates to speak.
Okay, the first problem we need to face is residential data security. We can use HTTPS to encrypt location information during transmission. And we can encrypt section IDs and user tokens by using hashing. Last thing we can do is implement role-based access control to restrict access to residential data according to user roles. For example, user can access only 01 address. The second problem is credit card data protection. And what we have done is integrate the Stripe API to securely process user payment. By using Stripe, the software avoids directly handling sensitive card data, reducing security scope and risks. The third problem we need to face is integration complexity. We can apply the facade pattern to create a simplified interface for integrating third-party services like Stripe and Google Map. This pattern hides API complexities and help prevent unauthorized access to sensitive components. The last problem we need to face is Firebase configuration. In this problem, they use the singleton pattern to ensure only one instance of Firebase configuration is active, avoiding conflicting connections and improving reliability.
Okay, thank you. So here is a class diagram to illustrate the system design of the home sales application. So firstly, to ensure the security of the residential data, the location class and user class in the class diagram are aligned with the decision to use HTTPS to encrypt the residential data and the role-based access control for managing user access. The user class has a field for address information, and the strict access control is enforced to manage who can access and modify this data. Secondly, the strict payment class and the payment processor class reflect the decision to use the strict API for handling payment information securely. Payment data is processed using strict class instance directly. This ensures that the user card details do not enter to our servers. The payment processor class provides a method like a process payment to work with the strict integration. This minimizes software security scope and also minimize the risk of the handling sensitive payment detail directly with the backend. And then to mitigate the integration complexity issue, the facade pattern is applied in the design of the classes like payment processor classes and the Firebase auth service class. These classes provide a simplified interface to more complex systems such as Stripe and Firebase. By doing this, the system hides the complexity of the multiple third-party APIs. And this creating a single point of entry for handling authentication and payments. This design makes the integration more manageable, reduce the risk of API misuse, and allows only wireless requests to be processed. Lastly, to ensure the Firebase instance initialization consistency, the Firebase auth service class reflects the implementation of the singleton pattern to ensure that only a single instance of a Firebase configuration is running across the whole application. This approach prevents multiple reinitializations that could lead to the configuration inconsistencies, like duplicate the network request or overwritten data. So this improves the overall system reliability. And that's all for us today. Thank you for your listening.